Welcome back, ladies and gentlemen. For this video, we will be talking about vector questions that are generally represented in a graphical form, okay? Where you will usually have questions of OA, OB is equals to A and B. These are actually your vector routes. Then, vector routes are always in capital letters, whereas vectors, the direction as well, is actually just in small letters. For this video, to prevent confusion, I would actually use a squiggly line at the bottom to let you know that the lowercase letters are actually the vectors, okay? And then one more thing to remind everyone about is that if the vector is parallel or collinear, that means they fall on the same line, they are always like some form of multiple of each other. The example that I have given here is AB is equals to a multiple of OA. Okay, so if there are like consistent multiples, then they can be in a form of parallel lines or collinear. Okay, so now let's look at the first question together here. The diagram shows a triangle OAB. The point P lies on OA. Sorry, the point P lies on AB. The ratio AP-PB is 1 to 3. Given that OA is equals to A and OB is equals to B, find an expression for OP in terms of A and B. Simplify your answer. Now, when these questions come out, it's actually pretty straightforward. All you have to do is route out the proper pathing, the proper vector routes. So for us to get from O to P, the breakdown of it would be that it would actually take you from O to A and A to P like this. So O to A plus A to P. Okay. Then from here, we will try to break down the question further. O to A actually has a vector already, which is actually represented by A. Okay, yeah, notice that this is lowercase a. Whereas A to P, as mentioned earlier, APPB is a ratio of 1 to 3. So this is 1 part and this is 3 part, making it a total of 4 parts here. Then, like I mentioned, A to P is 1/4 of A to B, which I will write down like this, 1/4 of A to B. Okay, I like to break down the questions as much as possible so that it becomes very easy to obtain the correct answer. Now, A to B, there is no pathing here, right? So we actually have to take the vector routes here to here again. So once again, A to B is actually negative A plus B, right? This is A to B. Now they're all in vector form, right? Vector form here. So this is 1 over 4 plus A. From here, all we have to do is simplify the equation. A minus 1 over 4A plus 1 over 4B. Final answer is equals to 3 over 4A plus 1 over 4B. Okay. Now, in the next question, vector Q has a magnitude of 12 cert 5. This question is not related to the top part. Okay. So vector Q has a magnitude of 12 cert 5 and direction of 6, negative 3. Vector R has a magnitude of 15 cert 2 and direction of negative 5, 5. Find the unit vector in direction of Q plus R. First of all, as with all these questions without the graph, I would always encourage you guys to sketch out the diagram. 6, negative 3 is generally 6 here, negative 3 here. The direction will be this direction here. 6 and negative 3. Okay. As for R, it is negative 5 and 5. So it will be this direction here. Now, what we want to do is we want to find the magnitudes of this and this respectively. Okay. So going back to Q, For Q, it is actually 6 square plus 3 square, or you can put negative 3 square, it's the same thing. Square root this answer, you would have cert 36 plus 9, 45, which gives us a value of 3 cert 5. As you can see, the real magnitude of Q is 12 cert 5. So there is a multiplier of 4, or you can say that you use 12 cert 5 divided by 3 cert 5. The multiplier here is 4. This 4 will be multiplied with the direction. So 6 negative 3 times 4 to give you 24 negative 12. Okay? 24 negative 12. Then the real vector for this is something like that. The next thing is for R, sorry, I should write down here is for Q. Q is equals to this, whereas for R is actually 5 square plus 5 square root this answer here. 25 plus 25, 50, square root of 50 breaks down to 25, 25 and cert 2, which will give us 5 cert 2. Okay, then the multiple, as you can see here as well, is 15 divided by 5 cert 2, 15 cert 2 divided by 5 cert 2 to give you 3, and the multiple 3 here, R, is actually equals to 3 multiplied by negative 5, 5 to give us the final answer of negative 15 and 15. Okay, that's for R. Now that we have Q and R, we want to find the unit vector in the direction of Q plus R. So Q plus R is actually 24, negative 12, plus R, which is negative 15, 15, to give us a value of 9 and 3. 9 and 3. Now, we know that this is the I and this is the J, and to find a unit vector, once again, we have to find the Pythagoras, the square root of it. Yeah, Pythagoras, right? 9 square plus 3 square root this answer here. This is actually the square root of 81 plus 9, 90. Square root of 90, can we simplify this? Probably not. So to find the unit vector, finally, unit vector is actually 9i plus 3j over cert 90. Okay, then we are done for this question here. Okay, next question. The diagram shows a triangle OBC. OA to OB is 4 to 7. OD to OC is 4 to 7. So let's write that down. OA to OB is 4 to 7, which means this is 4 parts here and this is 3 parts here. Same thing over here. OD to OC is 4 parts here and 3 parts here. OB is actually B. So we know that this whole thing is B, right? Vector B. And OC is C. Okay, vector of C. Point P is the point intersecting A to C and B to D, such that AP is equals to the lambda of AC and BP is equals to the micro of BD. Now, usually I would actually highlight these two words because these are what we are going to be looking for in all the cases of this. Then the question is, find two expressions of OP, each in terms of B and C, and a scalar, and hence show that P divides both AC and DB in the ratio of 4 to 7. Now, let's start off with this first one over here first. What I'm going to do is I will actually rewrite this part here. Oh, sorry, OP, right? We are looking for O to P. So I should rewrite OP is equals to probably cross path with one of this. Let's see how do we get from O to P here. We can take this path here, O to A, then A to P, which actually is given in this question here. So this is the first path that I would take. For me to get to O to P is actually OA plus AP. Okay, OA plus AP. Then let's simplify it from here. O to A is actually 4 over 7 of O to B, which is small b here, right? Plus A to P is given here as lambda A to C. To break down AC is actually A to C is actually this way, A to C, okay? Which means it is A to C is AO plus OC. The more you are able to break this down, the easier the question becomes. Plus 4 over 7b as from earlier. Okay. Now, O to A to O is actually negative of what we had earlier. Negative 4 over 7 of B. Plus O to C is just C, right? This whole thing multiplied by lambda to give us 4 over 7 plus B. We can try to group up the like terms here. You would end up with 4 over 7 minus 4 over 7 lambda. This is your B vector. Okay, B vector here. And then plus with lambda of C. This is your C vector, right? Then this is as simplified as we can get for OP. This is your first expression. Now, in your second expression, once again, we are going to look for OP, probably using this term over here now. O to P can also be, the alternate path for O to P would be either here to here, or here to here, or here to here. But we will take this route here specifically because it mentioned BP is equals to micro BD. So you have to find the clues of which route you use from your question. Okay, so OP in this case is O to B plus B to P. Okay, exactly what we mentioned here. So to simplify O to B is just B, right? Plus B to P, which was micro of B to D. Now, to break down B to D, it is actually traveling this way and this way, right? B to D. So this would actually equals to B to O plus O to D. These are all vector routes with the arrow on top, right? This is your proper vector. Now, from here, we can continue to write down and break it apart. B to O is actually negative B. O to D, as mentioned earlier, was 4 over 7 of C. Right? All these are vectors. Now, from here, we can again group up the like terms. In this case, factorize out the B. We have 1 minus micro of B plus 4 over 7 micro of C. Okay? Then these are your two expressions for OP and OP. OP and OP. Now, what we want to do is, in all these cases where we have these micros and lambdas together, we are actually going to equate the like terms together. This is the like term. B is equals to this B here. C is equals to this C over here. Because they are both OP. So let's form the equation. 4 over 7 minus 4 over 7 lambda is actually equal to 1 minus micro of B, right? From here, we can't really do much with the simplification, but If we were to look at the next one, lambda of C is equals to 4 over 7 micro of C. Then, as you can see here, you will be able to get a simultaneous equation. Since this is AddMaths, you don't really need working to solve simultaneous equations. All you have to do is represent the equations like so. Then type everything into your calculator. You will have gotten that micro is equals to 7 over 11 and lambda is actually equals to 4 over 11. Okay, this part you can just type into the calculator. Now, lastly, they want us to prove that P divides both AC and DB in the ratio of 4 to 7. What we're going to do is we can go back to the previous question here. Previous clue up here. AP over A to C is equals to lambda, right? And therefore, AP over AC is actually 4 over 11. Then we can actually look back at our graph here. A to P and A to C, this is 4, this is 11, right? Therefore, A to P to P to C will equals to 4 to 7. This is the first part. Then for dB, you can do the same. dB is this equation over here. This equation over here where you have BP over BD is equals to micro. And micro is 4 over 11, right? BP to BD is 4 over 11. Therefore, since B to P, this is 4, then this is 11 as well. This is 11 as well. Then we can say that BP to PD is also a ratio of 4 to 7. And there you will be done with your first question here. The point Q is such that OQ is equals to 2 over 7B plus 2 over 7C. Use a vector method to show that OQP are collinear. Justify your answer. So, as mentioned, collinear is when you have a multiple of each other, right? Then, from our previous equation, O to P is actually equals to O to P is actually equals to either this equation here or this equation here. Since we've gotten lambda and micro already, what I can do is I can straight away simplify the whole thing and I will be able to get that O to P is equals to 4 over 11B plus 4 over 11C. Right? Then, as you can see, they are actually a multiple of this, even though the multiple is a bit weird. What you want to do is you can actually use 2 over 7 divided by 4 over 11. And this is actually equals to 14 over 11. You will be able to do the same for part B. For the vector of C as well. Okay? So therefore, we will write down the justification is O to Q is a multiple of O to P. So therefore, they have a point in common and is collinear. Okay? You just have to phrase it with containing these kind of words here, multiple, then you will be able to score the second mark. Okay?